This is an application of solving a radical equation related to geometry. So we are given in this case the formula to find the base of a square base pyramid. So we're going to find the length of the side of the base. And so they give us that formula where V is volume, H is height, and B is the length of the base. They also give us some information about the Great Pyramid, which is that the distance around the bottom, which is of course going to be the perimeter, is 921.6 meters, and the height is 146.6 meters, and we're trying to find the volume. So looking at our equation here, volume is not by itself. I've got a lot of other stuff going on. So let's look at how we might be able to manipulate this equation so that it's V equals instead of B equals. If I'm trying to get V by itself, I might square each side because I know that that's going to get everything out of this radical. So that's going to give me B squared equals 3V over H because this and that index of 2 canceled. I still don't have V by itself, so I'm going to multiply by H. So I have H times B squared equals 3V, and I still don't have it by itself, so now I'm going to divide by 3. So to find the volume, I'm going to take the height times the base squared and divide it by 3, and that should give me the volume. Now, I'm going to plug in values that I know. So what do I know? I don't know volume, obviously. That's why I isolated it to try to figure out what it is. I do know the height is 146.6. And I don't know the base, but I know that the perimeter of the base is 921.6. So obviously, if I take that divided by 4, that's going to give me the length of one side of the base because it's a square, and so all of the sides are equal. And that gives me 230.4. But I'm going to square that value. And then, of course, I'm going to divide all of that by 3. And then from here, I'm just going to use my calculator. So I'm going to square 230.4, then multiply it by 146.6, and then divide it by 3. And when I did all of that in my calculator, I got 2,594,045 and 952 thousandths, and that's cubic meters. Here is a similar application for you to try on your own, so try it, then press play to see how you did. In this case, we have an isosceles right triangle. Remember, that would be a right triangle, meaning one right angle, where two sides, the two legs, have the same length. So the length of each leg is radical 2a, is what they're telling me. Radical 2a, where a is the area. If the legs in the triangle are 9 inches, find the area. So it might be helpful for us to go ahead and get a by itself first. And it's personal preference. You might just plug in the values as you have them and then solve from there. This would give me side squared. This would give me 2a. And then I would divide by 2, which would give me side squared divided by 2 equals area. Now, before we actually plug in values, let's look at a right isosceles triangle. I know that in a right isosceles triangle, I would take 1/2, in any triangle, I would take 1/2 times base times height. Now the base and the height are going to be the s, which is the length of the leg. So this equation totally makes sense because this would be 1/2 times s, or 1/2 times s squared, which this is just another way to write that. So yes, we did the math, but make sure it makes sense in terms of the question as well. So now we're finding the area. So the legs of the triangle are 9 inches. So the area would be 9 squared divided by 2, or 1/2 base times height, which of course is half of 81. And half of 81 would be 40.5, and that would be square inches.